In this final section, we're going to start taking a look at the last part of our first statement and argument forms, and we're going to start talking about arguments and argument forms. An argument is basically a sequence of statements, and an argument form is a sequence of statement forms, and we'll see specifically what these look like in a few moments. All statements except for the last one are called premises. Right? And a singular will be a premise. And the final statement form is called the conclusion. All right. There's only one conclusion. There's usually multiple premises, but it could be one premise and a conclusion. All right. Now, an argument form is valid if no matter what the particular statements are that are substituted, the conclusion is also true. And there's a number of ways that we can go through and to be able to verify whether an argument form is valid or invalid. The first one we're going to use is a truth table. And the truth table, as we see, it works all the time, but sometimes it's a little bit taxing to be able to do this just because it requires a lot of making sure that we keep all of our rows correct. And it's a lot of bookkeeping when we do it. So here's how we're going to do this. We're going to construct a table for all the premises and the conclusion. And any row in which all the premises are true is called a critical row. All right. So if we ever get a premise that's false, we just automatically omit that. We don't even care about it. If the conclusion is true in all the critical rows, then the argument form is valid. All right. And we're going to take a look at a few of these to where we can go through and figure out whether they're valid or invalid argument forms using the truth table. So this is an argument form right here. So we have a premise, P implies Q. We have a premise, Q implies R, and therefore P implies R. And P could be, if I am tall, then I'm good at basketball. And then if I'm good at basketball, then I'm rich. So hence, if I'm tall, then I'm rich. And that's what we're saying if we were to insert P, Q, and R for some specific statements. That doesn't mean it necessarily makes any sense, but logically it makes sense. All right, so let's see if this is a valid or an invalid argument form. So first thing we're going to do is we're going to draw the truth table, and just like we've done a number of times. So we need a P, a Q, and an R. And hopefully I have enough room in here. So 4 trues. So remember the trick, 4 trues, 4 falses. And remember 2 trues, 2 falses for the second row if you have 3 statements. And then you just toggle the last ones, true, false, true, false. All right, so we're going to need to figure out what the 2 premises are. So we have P imply Q, and when I say what they are, what their truth tables look like, so or their truth values. So we have P implies Q, and Q implies R. All right, that's going to generate our critical rows. All right, so the good news is P implies Q is always true unless we have a true implies false. And right here, when we have true implies false, those are the only 2 falses right there. All right, the rest of these are going to be true. All right, so here's the good news. As soon as you get a false, remember we said that a critical row is any row in which all the premises are true. So clearly the premise isn't true here. So we don't even have to worry about rows 3 or 4 in this problem at this point. Right? Now, we're going to figure out what Q implies R looks like. All right, and again, as soon as we see a true implies false, that's a false. So the only time that that's true is row number 2 and row number 6. So this one's false and this one's false. So right away, just like we did before, we can cancel out row 2 and we can cancel out row 6. The rest of these are true, right? Because we have a true implies true, we have a false implies true, we have a true implies true, and we have a couple falses. So this is true, and this is true. All right. So these are our critical rows. So here's a critical row, here's a critical row. So row 1, row 5, row 7, and row 8. And now what we're going to do is we're going to look at the conclusion. And the conclusion is P implies R. All right. So let's go ahead and see whether or not the conclusion is valid in all of those critical rows. And if it is, then we have a valid argument form. If any of them are false, then we don't. Right? So we have true implies true. So that's a true. So far we're good. Then we have right here, false implies true, and that's good. Then we have false implies true, false implies false. So what we state is that the argument form is indeed valid because the conclusion is true in all critical rows. All right, and I did run out of room to write that, so let me just make a little bit of room down here. So we're hopefully, oh boy, a lot of good my computer science degree is doing right now, right? All right. So we're going to state that since the conclusion is true in all critical rows, the argument form is valid. All right? And we're going to take a look at specifically what this is one of the more commonly used argument forms. All right, so we're going to see that a little bit later, maybe in the next video. All right, so another example. So we have P or Q. P implies R, Q implies R, therefore R. All right, so let's go ahead and do this one. And we're going to set it up the exact same way where we have our P, our Q, and our R. So we have P, we have Q, and then we have an R. And just like we had before, 4 trues, 4 false. And then 2 true, 2 false. And then finally toggle true, false, true, false, true, false, and surprisingly true, false. All right? And P or Q. All right, so we have a disjunction. And remember what a disjunction is. Disjunction means that one of the two of the premises has to be valid, or one of the two statements. So right away we know in P, the first 4 are true. Right? And if we look at Q, the next 2 are true. And then finally we get 2 falses. And just like we've seen before, as soon as we see a false, that row goes away. P implies R. So remember, the only time that P implies R is false is when P is true and R is false. So right here, we have a true implies false. So that's false. So we can get rid of that row. And we have a true implies false right here. So that's false in row 4. So it's nice that we can reduce our work just by identifying these false statements from the conditional. The rest of these are true. All right, so we have a true implies true here, true implies true here. So you get the gist of this. All right, so moving along, I'm going to clean this up just a little bit before we move on. Okay, the last premise that we need to worry about is Q implies R. And again, if we have a true implies false, that's no good. All right, so true implies true, so we're good there. This is a false implies true, so that's true. Here we have a true implies true, but then we have a true implies false for row 6. So this one's false, so we don't care about that. So we only have 3 critical rows, so that's nice. So we have critical row in row 1, critical row in row 3, critical row in row 5. The rest of them all are not critical. Well, the only thing that we care about now is the conclusion, which is R. And what's the value of R? Well, R is true. All right, so far, so good. All right, so that one's good. Over here, R is true as well. So that one's good. And then right here, R is true as well. So it looks like that once again, we have another valid argument form. Right? And again, I'm going to show you that this is one of the more commonly used argument forms. So once again, what we would state is we would state that since the conclusion is valid in all critical rows, then the argument form is valid. All right, so that's how we use a truth table. Now, unfortunately, what we know is with truth tables, as soon as we start getting more than 3 statements, then it starts getting a little bit unwieldy because then we'd have 16 rows. What if we had 5 statements? Well, then it'd be 32. And you could just imagine trying to do 32 rows, how difficult that would be. So our next video, what we're going to do is we're going to take a look at other ways to be able to verify and also refute these argument forms to determine if they're valid or invalid.